ShopRite has always been here for you. And our promise to bring you low prices on what you need most will never change. Like 3 kilos of Polana macaroni, only $69.99. And 2 liters of Nola sunflower oil, just $46.99. Only at ShopRite. Lower prices you can trust, always. One stop, one safer shop.
With the organic chemistry, I want to set up like a flow chart. We have alkanes. What reactions did we have with the alkanes? Just to sort of summarize. Here we had, first of all, combustion. Because they are hydrocarbons. Now, the products are carbon dioxide and water vapor. Then the next set of reactions was something called substitution. We could take off something and we could add a different element, one of the halogens, for example. Okay? But it was a substitution reaction. Then we said we can crack an alkane. Okay? And we didn't really go into much of it, but we can polymerize an alkane as well. Okay, cracking and polymerization. If you read up in your textbooks, you will see they refer to something known as reforming. We won't go into reforming, but what they're going to do is they're going to change the shape into whatever one they want. Okay. Now, how do we go from an alkane to an alkene? We crack an alkane. Are you all with me? Then we get the group of compounds known as alkenes. Okay, now alkenes can also undergo combustion because they are hydrocarbons. They do not undergo substitution, they undergo addition reactions. And what can we add? We can add hydrogen, we can add water, and we can add a halogen. Those are the main reactions with the alkenes. Now, I can go and I can go back from an alkane. An alkene, I can go to the alkane by addition of hydrogen. All right? When I add water to an alkane, I get alcohol. All right? The alcohols. The alcohols we had a look at yesterday: methanol, ethanol, propanol. Okay. Now, today, the next step, if I open up a bottle of wine, and I drink half of it, and I leave the bottle of wine standing around open for a week or two, what happens to the wine? It becomes sour. It actually reacts with the oxygen, and that is why when they seal bottles of wine to store for many years, there mustn't be any oxygen in it. Because if there is oxygen in the bottle, the alcohol will oxidize and it will form something known as a carboxylic acid. Now, first of all, it's an acid. So it has a pH lower than 7. The most commonly known carboxylic acids for you people would be vinegar. Vinegar is a carboxylic acid, and that is what forms when the alcohol in the wine is left to oxidize. It forms vinegar, which is a carboxylic acid. Okay, so how do we recognize carboxylic acids? If I take ethanol, and I allow it to oxidize, I will get a carboxylic acid, and the carboxylic acid will look like this. There is the original part there, and we will get, keep the carbon there, we will get double bond oxygen, OH. There is our carboxylic acid. It's just, it doesn't have to be like that. It doesn't matter. Okay, now that is an indication of a carboxylic acid. Remember, how do I recognize an alcohol? There is a hydroxyl group. Okay? We call this the carboxyl group. We can also write it RCOOH, or without the hyphen. The R is just the rest of the hydrocarbon tail. It's that part. Okay, so that R part can be a carbon and a carbon and a carbon and a carbon with hydrogens on it. You follow? Okay, so sometimes they use R accent. It just means there's a different molecule. Okay, to this one that I had. Now, the carboxylic acids, how do we name them? Well, the ending is something oic acid. What would this thing's name be? The prefix depends on the number of carbons. So I don't have methane, I've got ethane, but I don't have ethane, I have a carboxylic acid. So it becomes ethanoic acid. Okay? What would this one's name be? Say it. Methanoic acid. No. Okay. What would this one be? Yes. Propanoic acid. Butanoic acid. Do you follow? Now, okay, they also don't go much further than methanoic acid and ethanoic acid. All right? So you need to be able to recognize it. All right? They are all acids. In other words, if I add them to water, they ionize. Okay? Now this thing, I can also write it CH3COOH. Do you remember chuku? Yes, that's vinegar. Okay, can you see where it comes from? CH3, 1, 2, 3 hydrogens. There's my carbon, double bond oxygen hydroxide group. Okay, now, how does a carboxylic acid ionize? What would that reaction look like? Well, we will have CH3COOH. Now, what happens when acids ionize? For example, if I had hydrochloric acid, I get ions. Okay, now which hydrogens would form the ions? Because I have 4 hydrogens there. No. Unfortunately, it is that one. So what would this thing look like once it's ionized? We have CH3COO plus hydrogen. Yes, it ionizes partially. Now, you haven't done equilibrium reactions, which simply means it doesn't really want to get rid of that hydrogen. It actually wants to stick onto that hydrogen. Okay. It's a weak acid. Okay, so the ionization reaction for the carboxylic acids, it is just this hydrogen on the carboxylic group that ionizes. No, the others remain on the molecule. You mustn't let that confuse you. Yeah, if you go like that, I will draw it like that. There. This is what it looks like. Yeah, it is just an inherent property, and that is what it does. Okay. Are you with me? So the ionization of the carboxylic acid, it is that hydrogen. So if I had propanoic acid, then I would have, well, propanoic acid looks like that, methane, ethane, propane, OH. So there are my hydrogens. So I would have C2H, 1, 2, 3, 4, 5, COOH. How would the ionization look like? Yes, I will get the hydrogen plus C2H5COO and minus because it's a negative ion. All right, do you follow that? If you struggle to write it in this form out of your head and they want it in that form, just draw the picture quickly in pencil and work from there. All right, it shouldn't be very difficult. Okay, so the organic acids are there on page 138 in your textbooks. They say right at the top of the page, when an alcoholic drink is left around open in the air, it turns rather unpleasant and acidic. This is a natural process caused by bacteria. The alcohol is oxidized. Yes, I think so. Technically it will. It is oxidized. Yes? Yes. Julle moet basic carboxylic acids doen. Alright, the acid produced when ethanol is oxidized is called ethanoic acid. Its old name is acetic acid. Its common name is vinegar. The next, acetic acid. The oxidation of ethanol, which bacteria are able to do using air as the oxidizing agent, can also be done in the laboratory using a suitable oxidizing agent like potassium permanganate or potassium dichromate. One of the sections we still have to do is reduction oxidation reactions. It's just a short module, 3 pages. All right, so that connects up there. Then, if you go down one paragraph, the ethanol is heated with some of the oxidizing agent. The mixture is then distilled, and the fraction distills around 118 degrees because the boiling point of ethanoic acid is 118. Okay, the liquid collected will have a strong vinegary smell. Organic acids react in 2 characteristic ways. Like all acids, they will react with alkalis, and they will also react with alcohols. Now we will do the reaction of alcohol in the next period. I don't want to do it now because then you'll be totally confused. Okay, so at this point I will stop.
Insurance is the best safety net you can buy yourself. It is something good you do for yourself because should anything happen to any of your assets, you will be okay. Luckily, it also doesn't have to cost you an arm and a leg. More affordable, yet still reliable options are available in Namibia. The right insurer will get you financially prepared for accidents or emergencies with insurance for your phone, car, buildings, or your business. Let the Good Deal Namibia help you stretch your dollar by directing you to the one insurer that promises decreased premiums the longer you are insured. For a quote, simply SMS INSURE to 555 and we will call you back.
Organic chemistry. In the previous period, we've had a look at the carboxylic acids. Just to recap, we said from the alkanes, we can go to alkenes. How do we do that? Cracking of an alkane. Okay. From an alkene, I can go to alcohol by the addition of water in the form of steam, and from an alcohol I can go to a carboxylic acid. And this is by oxidation of the alcohol. Okay. Now, people, I want to carry on with the carboxylic acids at this point. And the carboxylic acids, they in turn can react with alcohol to form an ester. Okay. I am on page 138, more or less. And then 39 to form the esters. Okay. Now, how does this work? If I have an alcohol, let me do them in different colors. Let's just take propanol, OH. And I am going to take ethanoic acid. I'm just not going to draw the functional group on this side, I'm going to draw it on that side. So, ethanoic acid, OH, there we go. Okay, and now we are going to show how the ester forms. Now, it's a polymerization reaction, okay, where one molecule joins onto another one, but we find that a water molecule or a molecule similar to water is split out as a result of this reaction, or is formed as a result of this reaction. So what happens is that the hydroxyl group on the carboxylic acid and the hydroxyl group with the alcohol, that is where the reaction lies. And we find then that eventually there. So what do we get? We are going to get that there, okay, my hydrogens. There go my hydrogens. What have I got reacting? So now we are going to get oxygen, carbon, double bond oxygen, carbon, and the 3 hydrogens plus H2O. Yes, of the alcohol. I'm not 100% sure. Okay. Yes. I want to take that away. It's just the other way around. It goes there. In actual, no, it doesn't really matter. It's not really important. Where's delete? There. Okay. It doesn't really matter because what you eventually show is that we have a carbon, oxygen, carbon, double bond, oxygen. All right? Now, we have to name this compound. So, the name of the compound, I have got methane, ethane, propanol, and I had ethanoic acid. So I will have propyl ethanoate. Okay? Yeah. Well, the propyl part is from the alcohol propane, a propanol. And the ethanoate, ethan, methane, ethanoic acid, is from the carboxylic acid. So it's propyl ethanoate. If I had ethanol and ethanoic acid, it would be ethyl ethanoate. Do you with me? If it was methanol, it would be methyl ethanoate. If I had propanoic acid, whatever, propanoate. No. Yeah, you won't do more complicated than that. All right. Okay, so if you look in your textbooks, right at the bottom of page 139, there at the top they have a heading, reaction of ethanoic acid with alcohols. The product that is formed is an ester. Okay? We recognize an ester because it has this so-called ester link. There. Okay, carbon, oxygen, carbon, double bond, oxygen. That is the ester link. Now, right at the bottom of your page, page 139, there they have got ethanoic acid plus ethanol, and the product is ethyl ethanoate plus water. Well, yes, it must be H2O. Please fix it. All right. This is a condensation polymerization reaction, or just a condensation reaction because a water molecule is split out from the reaction. Yeah. Sometimes it can be something like sodium hydroxide. The Na just takes the place of one of the hydrogens and the OH group, because water in this form is actually HOH. So it could be sodium hydroxide would react similarly. Do you understand? Where the positive proton, the hydrogen ion, is the sodium ion replaced. Okay. But you will work with water. They won't really do funny, obscure stuff with you. They ask it fairly straightforward. All right. Okay, now, still in your books there on page 139, right at the top on the right-hand side. When ethanoic acid reacts with an alcohol, a substance called an ester is formed. The ester, if it is ethanol and ethanoic acid, is ethyl ethanoate. It has a sweet, fruity smell. People, if you have air fresheners that you spray, they smell like flowers and they smell like pineapples and bananas and all funny stuff. The fruity smells. Those are all esters. Okay. So take note. A sweet, fruity smell is an ester. Esters are very common in nature. The taste and smell of fruit is often caused by an ester. Now, fats and vegetable oils, although they aren't sweet smelling, are also esters. The difference is between the sweet-smelling esters, it's just the length of the chain. Okay, so fats and oils are esters. Any fat and oil contains esters. Yes. The cover tabletop, the laminated tops, is also an ester. It's just the length of the molecule becomes bigger and bigger and bigger. Okay. So, they say the solvent for removing nail varnish is an ester. It's got a sweet-smelling smell. No? Yeah, nail polish remover is an ester. We can compare the reaction of ethanoic acid with an alkali and with an alcohol. If we look at the equations, they are very similar. The big difference between them is that the reaction with alkali is an ionic reaction and the one with alcohol is covalent. So ethanoic acid with an alkali will give me a salt plus water. I just want to show you that. If I have ethanoic acid, methane, ethane, ethanoic acid. Yes. Why do you think I'm reading it? It's one of those obscure stuff that they want you to know. But it's just there. It says the one reaction is ionic and the other one is covalent. It's the third paragraph from the top of page 139. We can compare the reaction of ethanoic acid with an alkali and with alcohol. Okay? I'm going to do the alkali. Name an alkali. Yes, sodium hydroxide. So what is the reaction going to be? Well, the sodium is going to stick there, and the hydrogen is going to go there. Ah, well, so it is going to be like that, double bond oxygen. Now, we have that there. If the proton has broken off in an acid-base reaction, that thing is negative. The acid is ionized. Okay, so that is negative there. And this thing is sodium, is positive. So this sodium will go there. So what is the bond? Ionic bond. Say again? Yes, well, it's just, this part is negative. They say the reaction forms an ionic compound. Why is it ionic? Because positive and negative. I have an ion here, and I have an ion there. If I have sodium ions and chloride ions, I have an ionic compound. Now my ion is just very big. Coulomb forces. Attraction between positive and negative. Just like those are stuck onto each other. Yeah, well, be careful. The oxygen is bonded onto that part of the molecule. So the Na just goes there. No, you don't have to. No, it does. There's one is open there and there's the other one. Have a look. Look there. Remember I said acids ionize. What happens when they ionize? It forms an ion. It gives off a proton. That proton. Do you understand? Okay. Have you got it, Johannes? Oh. Okay, so this is an ionic compound. But when the carboxylic acid reacts with the alcohol, the product is a covalent compound. That's what we've just done over there. When that one reacts with that one, this thing that I have over here, let's take away all of that and that. This thing, let's go circle it with black. There we go. That whole thing is a covalent compound. Well, it's just covalent bonds. I don't have any ions there. Yeah. Okay, do you understand what that sentence means? That's what I'm trying to explain to you. I'll read it again. They say, esters are common in, third paragraph. We can compare the reaction of ethanoic acid with an alkali. That was the reaction with sodium.